Alright, in this video I'm going to show you how to solve quadratics using the quadratic formula. So first I'm going to start by showing you what the quadratic formula is. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we have a quadratic in standard form, which is ax squared plus bx plus c, an example of this would be, let's say y equals 2x squared plus 4x minus 5. We identify our a, b, and c. So a is the number in front of the x squared, which is 2. b is the number in front of the x, which is 4. And c is the constant, which is negative 5. So those are the numbers that we would plug in here. So when we say negative b, we would take 4 and plug it in there. Plus or minus the square root of b squared, so that would be 4 squared minus 4 times a. Well, a is 2, so I'd plug in 2 there. And c is negative 5, so I'd plug in negative 5 there. And then on the bottom I would have 2 times a, which is 2 times 2. So let's see how we would actually do this given a real example. So let's start with example 1. I have x squared plus 4x equals negative 3. So the first thing is we need to make sure that it's in standard form like this, where all of it is on one side. So I have equals negative 3. I need to add that to the other side. And I get x squared plus 4x. If I add 3 to the other side, I would get plus 3 equals 0. Alright, so now that it's in standard form, I'm going to identify my a, b, and c. So a is the number in front here, which is 1. b is the number in front of my x term, which is 4. And c is my constant, which is 3. So now I have a, b, and c. And what I do is I rewrite the quadratic equation with parentheses. So I would have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the reason that I put those parentheses is I'm going to then just take my number and plug it in there. So negative b, I'm plugging in b here, plus or minus b squared times 4a, which is 1, c, which is 3, all over 2a, which is 1. So I need to simplify this. And if I'm simplifying this, I get x equals negative times 4 is negative 4, plus or minus the square root. 4 squared is 16, minus 4 times 1 is 4, times 3 is 12, so 16 minus 12, all over 2. Simplifying this a little further, I have 16 minus 12 is 4, all over 2. And now we can simplify the square root of 4 because that's just 2. So I would get x equals negative 4 plus or minus 2 over 2. So if I break up this top, I would have negative 4 plus 2. Negative 4 plus 2 is negative 2, and I still have the over 2. And negative 4 minus 2 would give me negative 6 over 2. So my two answers here are x equals negative 2 over 2 is negative 1, and x equals negative 6 over 2 is negative 3. So my solutions are negative 1 and negative 3. So I use the quadratic formula to solve this. And remember, what you're doing when you're finding your zeros is you're actually finding where this quadratic crossed the x-axis. So my parabola, not quite sure where the vertex is, I just know that my parabola does cross these 2 points here. So this is my x-intercepts, my zeros, my solutions, whatever you want to call them. Alright, so let's look at a second example of this. So another example, let's say example 2 is 2x squared minus 7x minus 13 equals negative 10. And again, the first thing we have to do is make sure that this is set equal to 0, and right now I have a negative 10. So I'm going to add 10 to the other side. And I get 2x squared minus 7x minus 3 equals 0. And now I can identify my a, b, and c. So a is the coefficient of x squared, b is the coefficient of x, and c is my constant. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So plug in b, which is negative 7, minus 4a, which is 2, and c, which is negative 3. So if I simplify this, I would get x equals, a negative times a negative gives me a positive 7. Looking inside, I have a negative 7 squared, so negative 7 times negative 7 is 49. And I have a negative times a negative, if you see that. So the negative 4 times 2 would be negative 8. Negative 8 times negative 3 would give me positive 24. And 2 times 2, which is 4. So x equals 7 plus or minus 49 plus 24. So 3, carry the 1, so I'd get 73 over 4. So to simplify this, I would ask myself what the square root of 73 is, but it does not break down. So my solution is this. This is simplified as best I can. If I wanted to, this is the exact answer, right? 7 plus the square root of 73 divided by 4, and 7 minus the square root of 73 divided by 4. If I wanted these answers as decimals, I would plug in the square root of 73 into my calculator, and then I would, whatever decimal I get there, let's see, the square root of 73. Is 8.544. So I would have x equals 7 plus or minus 8.544 over 4. And then I would say 7 plus 8.544 is 15.544 divided by 4. And that would be 3.89. And then my second one would be 7 minus 8.544. So 7 minus 8.544 is negative 1.544 divided by 4. Divide by 4. And I get negative 0.39. In most cases, we'll actually have you leave it as the exact answer, but occasionally we will ask you for the decimals, so that's how you would do it. So let me show you one more example. Alright, so example 3 is 4x squared plus 6x plus 7 equals 0. So this one already has everything on one side, so I can go straight to identifying what A is, what B is, and what C is. And then my formula is negative B plus or minus the square root of B squared minus 4AC all over 2A. So B is 6, A is 4, and C is 7. So when I take this and I simplify it, I get x equals negative times 6 is negative 6, plus or minus the square root. 6 squared is 36. Negative 4 times 4 is 16 times 7. So 4 times 4 times 7, and that's negative, so that's going to be negative 112 over 8. So if I simplify this a little bit more, I have negative 6 plus or minus the square root. 36 minus 112 is negative 76 divided by 8. So first of all, I see that there's a negative inside of my radical, and I is equal to the square root of negative 1. So what that means is you can't have the square root of a negative number, and so anytime we see it, we take out an I. That's an imaginary number. So we should have negative 6 plus or minus I square root of 76 over 8. And so now I can worry about breaking down 76. So to break down the radical, I am going to see what multiplies to 76. And if I break that down, actually I'm going to do it without the radical for now. So 76 is 4 and 19. If you didn't know that, then you could say it was 2. 2 goes into 76 because it's even. And if I do that, it would go into, let's see, 76 divided by 2. That's 3 times, so it's 38. And then 38 is 2 and 19. So when I break that down, now that I know I'm doing the square root, I'm looking for what repeats or what's squared inside of 76. And so the square root of 76 is 2 square root of 19. So I'm going to replace this right here. So I have negative 6 plus or minus. Writing I2 is going to look funny, so I'm going to write 2I. So it's 2I square root of 19. And then the last thing I want to do is I want to reduce this these coefficients. So 6 and 2, I could take a 2 out of there. What I mean by that is there's a greatest common factor here of 2. So if I took out a 2, I would have negative 3 plus or minus I square root of 19 all over 8. And can't 2 and 8 reduce because 2 goes into 8 4 times. So my final solution here is negative 3 plus or minus I square root of 19 over 4. And now what does that mean to have an imaginary solution? What does that mean to have an I in there? So our solutions are where our graph crosses the x-axis. So here's my x-axis. That means that my quadratic is going up and doesn't cross my x-axis. So there's no real solutions here. It could also mean that my quadratic is going down and doesn't cross my x-axis. So it just means one of those two situations. It just doesn't have any real solutions because it doesn't cross the x-axis. So real quick, a recap on this one. When I got my A, B, and C, I plugged them in. And when I found that there was a negative inside of my radical, I took out an I. You cannot have a negative in a radical, so we take out an I because that's the equivalent of a negative inside of a radical. You could have also thought about this as a radical the square root of negative 1 times the square root of 76, and since we know that this is equal to I, that's why I wrote the I outside of the square root. And then from there, I just simplified the square root of 76 and found it to be 2 square root of 19, hence where the 2 square root of 19 came from. And the last thing I did was, since there was a negative 6 and a 2 and an 8, I knew all of these could be reduced by 2. And so if I divide by 2 here, I got negative 3. If I divide by 2 here, I got 1i. And if I divide by 2 here, I got 4. Now notice that I didn't do it to what's inside the radical. I did it to the coefficient of the radical. And so my final solution was this.